Okay, today I'm gonna dissect this jigsaw for you. This is a hand tool for cutting woods and light metals. So it has a reciprocating blade which goes up and down and can cut, for example, a piece of wood. So I already removed the blade. The blade should be connected to here. And now I'm gonna remove the casing to see different components of that. So this is an electric motor, which is the input of this jigsaw. And as I said, blade should be connected to this part, and that blade would be the output of the jigsaw. But the input of the jigsaw is rotational, but the motion of the output is linear. So we need a mechanism to convert the rotational movement of input to linear motion of the output. And here we have Scotch yoke mechanism to convert rotational to linear motion. So as I said, this is an electric motor. This is a fan to cool down the motor. And here we have small gear attached to the motor shaft. This gear drives the bigger gear, and the bigger gear has a pin here. Pin goes to slot of this part, which is called yoke, and when I'm rotating, for example, the motor shaft, this fan is attached to the motor shaft. You can see when this pin is rotating, we can have the linear motion of the output. So before dissecting it, let's go through two of the questions. First of all, question number 7, it's asking, are the up and down motions symmetrical in terms of velocity and acceleration? So I'm rotating the input shaft again, and you can see if the up and down motions are symmetrical in terms of velocity and acceleration or not. So for example, if it's going up faster than going down, it's not symmetrical in terms of velocity. But if it's going up and down with the same speed, it is symmetrical in terms of velocity. Okay, another question is the first question. Measure how many turns of the motor shaft it takes to produce one complete motion of the output. So here you can see a mark. I put a mark here. So look at the location of this pin and this mark and count the number of turns. One, 2, 3, 4, 5, 6, 7, 8, 9. I think the location is the same as the position that we started. You can calculate it from gear ratios or from your SolidWorks model as well. Now let's take it apart, see different components of that. And also there is a support here for the output. this is like a guide. When this output going down and up, we need two supports, here and here. One of them is missing here. But if you take a look at the e-drawing, you can see there are two supports here. This is the support. Okay, this is the yoke part. As I said, it has a slot. Pin goes to here, and blade is connected to here. This is the motor. You don't need to cat the motor. We need you to start from this gear to the output to here. And for this gear, you can just assume it's a simple cylinder in your CAD model. This part is stationary, this gear is rotating, so we need a bearing which goes here. This is the bigger gear. And this is the pin which goes into this slot.